Okay, good. I think we're all sorted. Hey everyone, I'm Tom McQuillan, work for JKI. JKI are a big LabVIEW contractor based in California, and I've been working with them for the last 6 or so months. And part of my role for working for JKI, I'm doing quite a few customer projects, but I also have the opportunity to work with the NI R&D team about upcoming features in LabVIEW, specifically where it comes to dependency management and dependency workflows. So I'm looking forward to sharing that with you today. Throughout this presentation, feel free to just shout out if you have any questions. If you come up with a question later on, please just send me an email, tom@jki.net, or find me on LinkedIn as well. Okay, so in this presentation, I'm going to go through a bit of a LabVIEW update from what's new in LabVIEW 23 Q1, a Dragon update, and what else? Oh yeah, random tips and tricks I thought of on the train up here this morning. Okay, so starting off with what's new in LabVIEW 2023 Q1. I'll just rapid fire through these. The first big thing is virtual environments for Python. So when I first started using Python, the first thing I did was install Anaconda, because that's what my online training course told me to do. And it was really easy and great to learn and install packages, but I couldn't connect it to LabVIEW. And that's what I am primarily, a LabVIEW developer. But now you can. What's up next? Anyone using a Mac? All of you, amazing. So great news. Now supported on macOS 13, which is surprising because it took NI a long time to get it supported on Big Sur, which was the OS before this. What's up next? Oh yeah, in your functions palette, you're going to come across the Fuse Design System palette, which to me looks remarkably similar to the NXG palette we had in previous versions of LabVIEW. But it's been renamed. The NXG palette still exists in your controls palette. So, duplication. Think of it as control reuse. A few other bits. Linux builds, you can now have your custom names and icons for your executables. I believe the way that works is you create a manifest style file and put that in the location of your Linux executable, where you define the name and your icon. Next, terminal height will always be 16 pixels. This is things like bundle and unbundle by name, property nodes, invoke nodes, constructor nodes, and the rest. I'm not sure if it's a feature or a bug fix, but it's basically if you change your default application font in LabVIEW, there were issues where your bundle and unbundle by name could get super big. But then it messes up all your wiring and those. Okay, on the theme of dependency management, NI included an NI package dependency finder, or missing dependency finder. So let's say you open up a LabVIEW project and you're missing DACMX. Well, the project itself will be broken and you'll still get that browsing search box, and that's still quite annoying. But when the project does eventually open, they've included a project provider where you can click on PD, which I think is for package dependencies. It appears here and it tells you, hey, what you're missing. And then there's an item to install. Okay, so that's all of the NI-based LabVIEW releases. The thing I wanted to talk to you today about, though, is where JKI fits into all of this. Who was here at GDevCon 3? A couple of us? Okay. So at GDevCon, Side note, tickets for GDevCon 4 are now available up in Glasgow. Early bird prices at the moment, make sure you get some. But at GDevCon 3, we had an announcement from NI about the NI and JKI partnership. Basically, this partnership means that JKI is now taking a leading role in the dependency workflows that we have in LabVIEW, and how we manage dependencies more generally. Who uses VIPM? A couple of us. Okay. Who here uses the more advanced features of VIPM, like configuration files? Okay, well, I'm going to demonstrate those to you now. Okay, so here I have a project open in, this is the latest version of LabVIEW actually, LabVIEW 23Q1, 64-bit. And in this project, I'm acquiring data, and I now want to publish that data somewhere. If I have a look inside the process VI, when that loads up, on the block diagram, you'll notice I'm using quite a few reuse libraries here. This center section, this is a JKI state machine, where you can just click and drop a brand new state machine down, and it has some advanced features as well. Around the outside, I feel like a web presenter now. Around the outside is the state machine objects, which basically encapsulates this process into an object-oriented design, so you can launch various descendants of this. And because these are all packages that I've installed, it means that whenever I need to open up a brand new VI, I can just right-click, perhaps go into JKI Toolkits, and place down a brand new state machine when it loads. There you go. And so now I can get started with actually implementing the functionality as opposed to implementing a case structure inside the while loop for this state machine. And I don't know if it's been properly defined yet today, but a package is just a unit of reusable code. Whether that unit of reusable code sits in your code base, like this code does, or if that unit of reusable code is a tool that you might use. So for example, if you go to Tools and look down here, I might not have any installed actually. But in your Tools menu, a lot of these are going to be packages. Packages that don't exist in your code base, but packages you use to create your code base. Okay, as I said, I want to publish this data that I'm acquiring somewhere. So I'm going to use, let's pick Modbus. Now, instead of creating my own Modbus drivers, I'm going to install a package that is already available. So inside VIPM, I can search for the term Modbus. It's going to do a quick search, and I can see the NI Modbus library. Now, here I was searching on VIPM desktop. We can click on the VIPM logo up here and open up the browser. And this browser came a couple of years ago. And inside this browser, notice how it's matching the search terms here. I get a bit more information about this package. So the NI Modbus library, hey, what, 27,000 people have installed this? I can see its star rating. I can click on it, get information about the licensing, etc. Okay, so now let's say I've installed this package and now my project is dependent on this package. Now comes the difficult task of how do I manage these dependencies? If I'm working with several other developers at JKI, how do I make sure that their PC is up to date with the package that I've just added? Well, the solution there is to use what we call a VI configuration file, or a VI package configuration file. So let's head onto disk. I'll just admit James McQuillan. Okay, awesome. So I'm going to use a VI package configuration file, a VIPC file. And what this file does, you can think of it as a big zip folder of packages that I'm using. I can just right click and open this with VIPM. And we'll give it a moment to load. I have a very exciting number of processes running on this laptop. So everything has slowed down significantly. Okay, there we go. We can see that it's loading in VIPM in a separate window. Okay, and you can see that I've got a couple of packages that I've linked already. The JKI state machine, there's like a toolkits palette, then the OpenG Boolean library. I now want to add the Modbus library. So to do that, I'm just going to click and drag from VIPM over to my VIPC file. And I can save this. And so the idea here is that I commit this to source code control. My colleague pulls that change and can then right-click my VIPC file and apply it. Then VIPM just updates your machine, and then you can successfully open the LabVIEW project. But let's say I've forgotten to add various packages to this VIPC file. Well, what I can do there is click on this Scan Project for Dependencies icon, select my project, and select Open. And let's have a look on disk. Okay, so now this exists in source code control. Imagine I've done my git commit push. My colleagues have pulled. My colleagues, with the current technology, can right-click and apply configuration. And that will open up VIPM, install the packages. They can then successfully open this project. Any questions, comments, or thoughts about anything I've shown you? Prior to LabVIEW 2023, what I've just shown you wasn't available. Or rather, it was available, but only to pro users, the ability to share these package configuration files. However, at the moment, yep.
As I understood in LabVIEW 2023, although the small package configuration is looking at the first one we talked about, not the second.
I will circle back to you on that one.
Okay.
So if I just have a look on the splash screen here, notice how I've registered this version, but I am using the free edition. Okay, so everything you see me do, you have access to. Okay. So I'm going to close this. Now, let's say the package that you want to use just doesn't exist. I've been learning the piano, and I have a digital piano at home, so naturally I wanted to connect my piano to LabVIEW. not for any particular reason, I just thought it'd be quite cool. I effectively have an 88 key waveform generator. Can I do something cool with that in LabVIEW? So I naturally went to VIPM. I was like, okay, hey, do we have a MIDI interface? Yeah, okay, what's the question?
It is, how does this handle when you have a different version of the package already installed?
Okay, so the question was, how do we handle different versions if one's already installed? At the moment, if you apply a VIPC file, the version into VIPC file is gospel. So it will either upgrade or downgrade depending on what you've selected. However, there is the confirmation dialog. So before you click install, you can say, oh, I already have a version greater installed. I'm going to deselect that line item. Okay, so MIDI stands for, I think, Musical Instrument Digital Interface. And there weren't any packages. The one you see here is called JKI Tom's MIDI project. This is one I created. But imagine this is all blank, because a MIDI library doesn't exist. So I created it, or rather, I created some of the functions. I have a library here with maybe 6 out of the 40 or so functions I need. What does the code look like? Oh yeah, all of the code is just going to be wrapping a Windows DLL. So let's say I've completed this, all 40 or so functions. Or even before I've done that, always build often, build early. In VIPM, I close that. I can create a brand new package, so open VI Package Builder, and that's going to take me through a wizard in order to create this new package. And on disk, I already have a VIPB, VI Package Builder specification, which I'll double click. Normally it is much faster than this, but I have just like Teams and screen sharing and everything happening, and it's in virtual machine. Okay, so here's my build spec. So build information, hey, I'm just going to point it towards my source directory. I have the output directory, major, minor, bulk, and build, much like what Stefan was presenting earlier. Then we go down to display information. Again, we have the ability to give ourselves a product name, icon, copyright, etc. Description, much for muchness. But then we get to palettes. Now in palettes, we can customize what your palette is going to look like. So if I click on here, this is simulating what your brand new palette is going to look like in the functions palette window when you right-click the block diagram. Notice here we have palette location. Currently, I've got it under functions in the MIDI driver. So I right-click my block diagram, which is only the functions. In the MIDI driver, it's just going to be a subfolder. Now what we can do is change this completely. If I wanted this to sit next to the TCP library in the communications subpalette, I could browse to that location. Okay. Now what we can do here is build it. This might take a while, so especially on this machine. So I'm not going to do it here, but you get the idea. This will output an artifact, i.e. a VIP file. And once it's built, it will give you the option, hey, do you want to install this, add it to your library? Do you want to share it with the LabVIEW community? So do you want to make it publicly available for any LabVIEW developer to download? And then once it's installed, you can right click and you'll see your driver here. Now this is a driver that you can use on any LabVIEW project on your machine. Any questions, comments or thoughts about anything I've shown you so far?
Is that still all available on the free edition?
Yes.
Because we tried it years ago with Ollie, trying to sort of use our common VIs into inner packages, but then we had to use the sort of pro edition for that. So is that where you can still create your own private sort of repository with the packages, or is that where you need the pro edition?
Yeah, so great follow-on question. So VIPM Pro still exists, and that's great for teams who are sharing code repositories like that. So in the Pro Edition, you'll be able to add a local code repository, and that could be the Rolls Royce internal code reuse. At JKI, we have a couple of subscriptions there. And so by default, we subscribe to the LabVIEW community network and the LabVIEW tools network. And anyone can see all of those packages in VIPM. For company-specific packages, you subscribe to them here. In them, they will appear in the list. Also in the Pro version, if you wanted to commercialize your packages, you could do in the Pro version using the IP protection features and integrate products like software key to license your packages. Any other questions, comments, or thoughts?
Just a quick one on the chat, Tom. They're asking about the command line API for the packages, which Stefan says that it does exist, but did it used to be part of the Pro version and now it's in the free version?
Great question. I don't know the answer to that one. The API itself is part of the free version. Whether that extends to a CLI, not 100% sure. Okay. All right. So, if you have any more thoughts about VIPM, VIPC files, building packages, let me know. Email me, tom@jki.net. So, I want to share with you something that's in a pre-release stage, something that I've been working on at JKI for the last for a couple of weeks, a couple of months now. And that's the opening Dragon portion of JKI Dragon. Dragon itself, well, part of the Dragon technology toolset is dependency management. The bit that I'm focusing on right now is to save LabVIEW developers from dialog boxes like this. Hey, this thing isn't installed, or we've been searching for ages and we can't find a particular package, whether that's from NIPM or VIPM. I have a huge list of missing items. There's this box which I never really know what to do with. Let's just click close and hope for the best. But also the other thing that I'm working on is solving this issue, where imagine you have an open source project. The source code is in LabVIEW 2015, but one of your contributors has decided to open it up in 2022, has saved it, committed it, and now your entire open source project is in the wrong version. And then you need to go through the painful process, as you inferred earlier, of back saving your LabVIEW project. So I've been working on dependency management in LabVIEW, and specifically the workflows. I view LabVIEW itself as a package dependency of your project. So anything that your project needs to open successfully is a dependency which I'm wanting to manage. Okay. So for those of you who haven't seen it, this is what the Welcome to Dragon welcome screen currently looks like. You can have your .dragon project, has location on disk, and your LabVIEW version. This one, 23, 64-bit. Now, in an ideal world, we go from this screen, we double-click where it says Open with LabVIEW 23, 64-bit, and it opens in LabVIEW. Great. So that's the path we want 95% of the time. Let's say we want to change that LabVIEW version. I have, let's say, 10 projects on disk. This one needs to be in 64-bit. A couple of others need to be 32-bit. A few others need to be LabVIEW 19 or whatever. The idea is different LabVIEW versions for different projects. So we can right-click an individual project, choose a LabVIEW version, and this is going to list all of the LabVIEW versions you have installed on your machine. It will grey out unsupported versions at the moment. So if it was saved in 2023, 22 and below is going to be greyed out. But equally, if it's saved in 15, all of the versions since then are fair game. Here, we're looking at the Dragon welcome screen. Double-click this to open my LabVIEW project. If we click Settings, we could just make it so the .lvproj file extension gets registered to Dragon. And so now you can just double-click your LabVIEW project file and go through a Dragon opening routine, or the Dragon workflow. Let's say there's something wrong with your project. Let's say there's some missing dependencies. So here, I've double-clicked on my LabVIEW project, or opened the Dragon project through the Dragon screen. It says, hey, 4 required packages are missing. What do you want to do? Well, there's always going to be the option for you to just say, I don't care. Don't install it, just open LabVIEW as fast as you can. Now, this project is going to be broken, but sometimes that's all right. Let's say you receive code from a customer, and you're doing a quick code review, and you just want to see the size and structure of the code, perhaps get an idea of where their programming ability lies. In which case, you don't need the packages installed, open it in LabVIEW. Alternatively, you say, yes, just install whatever you have to, and then open the project. So now in the secondary workflow, I click yes, install packages. It installs the packages, in this case through VIPM, and then opens the LabVIEW project. There's another button here of show details. Let's say you're thinking, well, hang on, the last time I tried this, it worked fine. What's changed? You can have a look at your development environment setup. It says here, hey, we were expecting a different version of LabVIEW. These items need to be installed. And to, was it your point earlier, of if you already have a version installed, what happens? Well, this dialog box says to be installed, to be upgraded, to be downgraded. If it's to be upgraded, it says this is the version we expected, this is what's already installed, and vice versa for downgrading. But you can check and de-check each of these line items, install selected, get back here, and then open your LabVIEW project. this whole workflow relies on the concept that we want to go from disk to LabVIEW and developing with as few roadblocks as possible. So in an ideal world, we double click on our LabVIEW project, it opens here, and the end user, everyone here, is none the wiser that actually a Dragon check has taken place in the background. And we're working on optimizing that routine. Yeah. Let's say we just have. Oh, did you have a question? Okay. Let's say we just have a project on disk like this one. Dragon doesn't know this file exists, doesn't know this project exists. So the first time we open this project, assuming we've enabled the Windows shell to double click open with Dragon or right click and then select open with Dragon, this dialog box appears. And the process that we're going through now is effectively configuring this project to use Dragon. We're going to choose, hey, which version would you like to use? And again, it's going to list the versions you have installed. So, hey, I want to use this with LabVIEW 32-bit. I click continue. It's going to ask about existing dependencies. Right. Hey, do you have a VIPC file already? If not, don't worry, we'll sort it all out for you. But in case you do, you can browse to it, or just let Dragon take care of things. Do you have questions?
Yeah. If a VI has a library membership change, does Dragon pick that up or not? So, as opposed to a dependency, if it's changed its membership of a library, i.e. the library's moved on, create a new one, would that pick it up based on your previous load or not?
So, in what I'm showing you here, no.
Okay.
But I've been doing some proof concepts into the way the LabVIEW linker works in the background, and that would pick up those changes. But that's a whole big scope of development work that needs to take place still. But yeah, on my mental roadmap.
Cool.
Okay, so regardless of the option you chose, let LabVIEW deal with it, let Dragon deal with it, or hey, no, I have my own configuration stuff. This .dragon folder will appear. You can treat that like your .git folder, and a project name .dragon file will appear. And the combination of these two items will store the LabVIEW version that you want to use, the various project requirements, project dependencies, etc. Using today's technology, we're also going to be linking with a VIPC file, subject to change in the future. But again, just to emphasize, the workflow that we want is you can click your Dragon project, your LabVIEW project, or from your Welcome to Dragon window, and get to where you want to be as soon as possible. For us, this isn't a marketing exercise. This is we want to change the way that dependencies are managed in LabVIEW, because at the moment, that's an area of weakness. You think of Visual Studio. If you open up a project in Visual Studio, it opens straight away, and it does all of the dependency checking in the background, and as new links are found, those project items go from disabled to enabled. And then, as something, if something can't be found, the user's not really notified until it's then being used, or the user double clicks it, and then you get an error message. Whereas with LabVIEW, it's just a pain to open your project to begin with if dependencies are missing. Questions, comments, or thoughts about anything?
There's another question in the chat.
Yeah.
Would there be a way to call Dragon to check dependency programmatically?
Yes. not in this pre-release, but yeah, that's in the pipeline for sure. This is something that Jim, my boss, Jim Crane, CEO of JKI, is very pleased with. I shudder to think how much development time he put into this, but it does make me smart. More importantly, though, the thing to take away from this is, as I'm scrolling up and down, notice this tip strip changing between LabVIEW versions. So I have multiple LabVIEW projects here in different LabVIEW versions. Here, I shall switching between 32 and 64-bit, but I think those are completely separate versions. It's nice, isn't it?
How many people actually have multiple versions of LabVIEW installed on their computer? Because I've always found it very troublesome. Oh yeah. Always go.
So there are a couple of camps that people tend to fit in. There's people who are downloading LabVIEW for the first time. They install the latest version of LabVIEW and they learn LabVIEW. They just use one version. There's another camp who download LabVIEW. If they notice there's an update available, and there's the type of people to constantly just update the latest version, not necessarily uninstalling previous versions. I suppose the 2.B version of that is what I was until JKI, where I'd be developing in, let's say, LabVIEW 2019, 2020, and the very latest version. In then there's JKI, where I only ever have one version. Most of the time, on customer projects, I'll have one version installed, but I have a separate virtual machine for every project. Shall we do some LabVIEW tips and tricks? Okay, this is just going to be a big demonstration session. If you'll humour me in that. Okay, so also what I'm about to go through has nothing to do with dependency management. This is just things that I do, even I realise that not many other people also do. Node setup. Oh yes, so what I'm about to show you here, please use as an inbuilt debugging feature as opposed to standard release feature. So the code here, I will still include in executables for release, but the way we access these features will be under lock and key. So I know how to do it, but I don't know my customer how to do it. I have some code here that I'm going to run, and these are both false. So this sub-VI here is currently running. And that's just running a daemon in the background, an asynchronous process. But hang on, I have no access to that process now. And this can be super annoying if you're trying to debug something. You know there's a bug, but it's that you can't just single step through and find that bug. In this instance, I can because I've made it on the entrance, so I can just double click it. But I can click OK, and everything closes, or everything stops. Let's say I have multiple clones running. And I know there's a bug, so I want to access a specific clone that's running. So I'm going to select Open Front Panel when called. So now this sub-VI is going to execute. I run this. Okay, front panel opened here. Again, this is a debugging feature. Don't use this as a quick hack to make your front panels appear and disappear. But now this specific clone has appeared, I can do things like right-click onto the block diagram, and this is the specific code that's running. and you can see that it's a clone. And all of my debugging features are available. Let's say the next debugging feature I want to do is suspend when called. Let's say I have a daemon that's running in the background. It's got a bug that I just can't track down. It's driving me insane, so I'm going to suspend that node when called. In this case, it's now going to execute. I run. You can see that it opened its front panel. Notice this run arrow. That run arrow looks a bit weird. This VI isn't running yet. This is the clone that's been launched, but it's stopped. It's launched and stopped. I now have the ability to open up the block diagram. I can brace myself for a session of debugging. Let's turn on highlight execution and start running. I can now trace what's happening in this clone. Furthermore, I can, hey, I missed that bug. That bug just happened, but I missed it. I'm going to skip back to the beginning of this clone. Turn off highlight execution and skip back to the beginning. Of course, it's not going to work in demonstration mode. But the idea is that you have the debugging features available. And once you're done, this code can stop. You can press this button. Think of that as like eject this clone, return back to my caller, and we're back to where I started. One thing that's important to point out here though, this VI, and this VI, these are all exactly the same VI. But what I've done is configure the node configuration. In standard behavior, if I right-click, go to call setup, if I right-click, go to sub-VI node setup, all of these buttons are unchecked by default. So whenever you drag down a VI, this is the configuration you get. In Open Front Panel, I right-click, VI node setup. I have Open Front Panel when called enabled. Okay. And in Suspend when called, I have Suspend when called checked and Show Front Panel when called checked. So often this cluster will actually exist in a configuration file for my software with some special keys that I know and the fellow developers know, but the end customer doesn't know. And this is actually being used fairly often in LabVIEW if you know where to look. For example, this is the Actor Framework Launch Root Actor VI. There's a debugging feature in here called Open Actor Core Front Panel. And if I just double click this, just bury down, notice we have Open Actor Core Front Panel, follow the money. It's being run here. This is the VI that's actually being launched. Follow that wire again. And then we have that case structure. That case structure is exactly the same as the one I demonstrated. If I right-click this one, sub-VI node setup, show front panel when called and close is enabled. If I right-click here, in default case, it's not enabled. So this is how you can have the same VI act differently based on your debugging needs. Okay, as I go through these, let me know if you have any questions. What's up next? Call setup. Okay. So So we have my splash screen here, which I spent a long time developing. I run this, the splash screen shows, and the code in the background, the code in the background isn't going to launch because I've not developed that yet. But typically with splash screens, this is the kind of code setup you have. You show your front panel, you launch some code with like a minimum wait time so your splash screen stays open for your browsing version numbers, and then you close. The interesting bit is how we implement this launching VI. If I look on the block diagram here, and this is why it didn't work, I forgot about this. You might want to load this VI from disk, and so it's not in memory when you launch your splash screen. So the splash screen opens really quickly, and then you can start loading everything into memory, open a reference, launch it, close the reference. That's all very well and good, except managing where your code path actually lives, especially if that code path is inside your executable, that can be a bit challenging. So instead, it would be much nicer if we could just use a static VI reference. A static VI reference brings it into memory. If I just enable VI. So when this VI is called, think of that just as a sub VI. And therefore, to load this VI, you also have to load all of the dependencies and everything before this VI will run. And so that's not very good either. Your splash screen is going to take ages to load up. So instead, I'm going to right-click this and do call setup. And I'm going to select load and retain on first call, and click OK. Notice how this has now turned into a call by reference VI. It has inbuilt configuration to tell you where that file path is. So as a developer, I don't need to keep track of where it lives. LabVIEW knows that. And so now when I run this, the splash screen can load immediately because it has no other dependencies, really, or nothing of value. But when this mode starts running, this is the moment where this VI gets called into memory. Is that enabled? Yeah. And so now when I run this, there we go. You can see it loaded. Cool. I'll speed through the next couple. The next thing I want to go through is the VI mode. Let's say you just want to see how this splash screen is going to look in runtime, in run mode. Just do Control M, and it will give you a preview. It will change the VI mode from edit mode to run mode without actually running the VI. And Control M again. And that's super handy for things like, if I look at the new Fuse design system controls, if I have a control like this, and I click on this text, well, it just asks me if I want to edit that text. But if I change it into run mode, it will now behave as if it's running, even though it's not. So I can sort of test drive my user interface without having to run it. Control M, and I'll delete this. So that's Control M. If I do Control L, that's going to open up the error list. And so this is handy if, like, I know that this VI is running okay, but I have a hunch that something in my project, something in memory is broken. Just do Control L, Bassel shortcut to bring up the error list. Number 5 is appending error information. Let's bring up this piece of code. Okay, so in this demo project, let's say I want to test my error handling, so I inject an error, and what's going to happen here is an error code just gets passed into my error cluster. So inject error, I get a single error handler. Great. Although it's not great because it gives me actually no contextual information as to where this error occurred. 1, 2, 3 occurred at identified location. That is just because I haven't given any information to the source. If I used, suppose I should have used an error ring here, or if it got returned from a function, it would tell me the location. But it doesn't tell me, hey, what frame in my state machine did this error occur in? Whereabouts in my code did this happen? And what was the current state of my code when this error code happened? Well, what we can do is append error information. So if I enable this subdiagram, down, there we go. Yeah. So here I'm now going to add some error information. I'll just run the code again. There we go. And inject an error. Hey, and now it tells me, hey, the JKI state machine case was inject error value change, and the last waveform value was whatever it read here, 0.317. And so this is something that I've been using all the time now. For things where I'm like, this could give me an error fairly frequently, so I'm going to sort of include more information about the context in which this error occurs. Let's have a look at the code inside here. What we need to do to include this is inside your source string, use the append flag in chevron brackets, angled brackets, and then you can add in your extra information. Bonus tips, you know that in LabVIEW 2019 onwards, you can right-click your case structures, add case after to handle specific errors, or at least when LabVIEW doesn't freeze in your demonstration. Okay, so we went through VI mode. From this view to that view, and you can check things like how UI items will behave. If you suspect something is broken, but everything seems fine, just do Control L to look at your error list. We've just been through this. This is what I wanted to show you down here. We can handle specific errors with case structures. Right-click, add new case, error code 123 for a timeout error. With the simple error handler here, if you want to develop your own error log, like save errors to a file, you can use a simple error handler, and there's a message indicator at the bottom. As an input, there's an enum input, where you can select things like show one button dialog, show warnings dialog with continue, show stop dialog. There's also a no dialog option. If you pass in the no dialog option, this won't display a dialog, but it will return the message, which you can then save to your log file. Window sizing. Let's see if LabVIEW has unfrozen. Yeah. Okay, window sizing. This is something that I've been using a lot. I'll just change the background colour here so you can see it more clearly. The border that you see here isn't a decoration. And by that I mean, if I try and select it, I can't. What this border is actually showing me is the window bounds that will happen in runtime. And the way that I can set that is I do Control-I to bring up VI properties, window runtime position. If I go for, normally it's going to be centered primary. When you choose your pane size, your panel size, then select that to current value, current size, scroll panes to origin at runtime, and then this border is going to appear to show you where those dimensions are. The nice thing with this is, if I go back here, if I start changing these values, it changes in the background in real time. So I don't need to instinctively know what these values should be. I can just move it until it looks about right. Oh yeah, and this is the last thing. One thing I've been doing a lot is to give the developer motivation comments. Here is a motivational comment. That's not what I'm talking about. Actually, no, by all means, you should do that. Let yourself know you're doing a great job. Sometimes at the end of a difficult pathway where I'm sending a message between lots of different actors, I might just put a one-button dialog box at the end of the sequence saying, "Good job, Tom, if you're reading this, it works." So, I'm not talking about motivational comments, I'm talking about motivation comments. This comment isn't great. It's telling me, hey, use open to open file. If the file can't be found, an error will happen. Use close to close the file. Well, yeah, I can work that out. I'm literate in LabVIEW. I can just look at the code and see that that's happening. I don't need a comment to tell me that. Instead, I need a comment to tell me what were the developer's motivations for writing that code. So I've now changed the way that I write comments in code from something like this, where if you're good at LabVIEW, you can work it out anyway, to say, hey, I'm assuming this file is in the same directory as a particular item. I decided to make it read-only because of this. If the file can't be found, this error will happen, and this is the consequence. This is why I'm doing that. The point I'm making here is good LabVIEW developers can work out what the code itself is doing, so that's sort of useless. What's very difficult is explaining to your code developers, this is the reasons why I did what I did. Okay, any questions, comments, or thoughts? No? Awesome. Well, in that case, thank you very much.